Hi, we're in section 6, chapter 6, section 3, working with normal random variables, general normal random variables. And in particular, I want to begin here looking at the problem from the notes on IQ distributions are normally distributed with a mean of 100 and a standard deviation of 16. What percentage of people have IQs between 115 and 140? So I have laid out here on the board a general layout for a general structure for how we really do these problems for section 6.3, general normal random variables. So we have the curve on the left having the specific parameters for the variable of interest. And then the curve on the right is always the standard normal. Okay, so the other piece, I think, to the layout of the problems is that in the middle we have z equal x minus mu over sigma, and that's going to be when we're given an x score, and we have to take that x score over to the z scores. All right. So the problem asks for the probability that x is between 115 and 160. So let's go ahead and 115, excuse me, and 140. So we'll put that on the x graph, x world axis there. And that's what we want to know. And so our process is to take each of these two x values and put them on the bus and let them come off in the z world there. So transform them. So we have the two values that need to be transformed. So the first one we're going to find is z of 115, and that's going to be 115 minus the mean of 100 divided by the standard deviation of 16. So calculators, let's go ahead and get that to 2 decimal places. Please work along with me with your calculators and take the notes. We're going to report this to 2 decimal places so that when we go to the table, the normal table will be all ready, because that's how we're going to need it for the normal table. Okay, so z of 115 maps to 0.94. And let's go ahead and also find z of 140. And that's going to be x minus mu, where x is the 140, mu is the 100, and the standard deviation is 16. So let's go ahead and look at that to 2 decimal places, please. We get 2.50. Okay, so what we have on the board is a statement that the area of interest is the proportion of individuals that have an IQ from 115 to 140, and that's equivalent to, using this transformation, the area under the standard normal curve from 0.94 to 2.50. Okay, so now we have, if we just look at the right-hand side, we have a problem that looks like a standard normal problem from section 6.2. So we have a bounded region, and the strategy in calculating the area in a bounded region is going to be 2 direct lookups and a subtraction. So once you go ahead and I'll work quietly on the board, you can work looking it up, and then when you're ready, check and see how we did. And I'm getting 0.1674, 16.74%. And that's going to be the area in both of the bounded regions, in both the X world and the Z world. Okay, and so this is the finished solution. Okay. So we're going to move on to the next problem. And what we want to do there is demonstrate the empirical rule for this particular IQ distribution. So, okay, so I'm going to decide that we'll demonstrate the second part of the IQ, the second part of the empirical rule for the IQ distribution, and also it will require stating the second part of the empirical rule for the standard normal. Okay, so that's my cursor. Tired here. I'm gonna get them a little nicer here. Okay. And so the second part of the empirical rule says that about 95% of our observations are within 2 standard deviations of the mean. All right. So, and I believe we worked in a previous video or in class where we found that that exact value was 0.9544. Okay, so what we want to do is we want to demonstrate the empirical rule, or we want to find the area for the 2 standard deviation interval. So let's figure out what that 2 standard deviation interval is. We want to go all the way to mu is 100, 100 plus 2 times 16, 100 plus 32, or 132. That's going to be the upper bound. And the lower bound here, the interval of interest, is going to be 100 minus 2 times 16. 100 minus 32, 68. Okay. All right. And so the area in question is the area within 2 standard deviations of the mean. So between 68 and 32. Now, we want to go ahead and put 68 on the bus and bring him out over here in the Z world. And I'm going to do that, but you might already know what that Z statistic is. Everybody might know how many standard deviations below the mean 68 is, because that's how we got it. But go ahead, I'm going to go ahead and find Z of 68. So it's 68 minus 100. Divided by 16 minus 32 over 16. Oh, minus 2. Yes, we had chosen 68 to be minus 2. That is, we had chosen 68 because it was 2 standard deviations below the mean. And so in a very analogous way, 132 is 2 standard deviations above the mean. And we would like to find out, oh, excuse me, because we're in Z's, we're going to be working with the Z table, so I want 2 decimal places. Okay. So what we want to do is find the bounded region between -2, the area in the bounded region between -2 and +2. So let's go back over to the formula cards and figure out what this is. 2 direct lookups and a subtraction. So the area to the left of 2 is 0.9772, and the area to the left of -2 is 0.0228. And now we subtract. And get 0.9544. Definitely a calculation we saw in a recent video or in class. And so what we have is a demonstration of the empirical rule for this IQ distribution, which is, and the statement is that 95.44% of the individuals in the population have IQs between 68 and 132. All right, so that's it for this video, and I'll see you in the next video.